Okay, so I am starting today the motion in a plane. Joylin, so I am starting from motion in a plane, na?
Okay, sir. Yes, sir.
And Divyangi, definitely I will discuss your doubts. Okay, so don't worry about that, and all the best for your exam. Okay,
Thank you, sir.
yeah. And one thing I want to say, right now you are in 11th class, and this physics of 11th class is not much difficult, but you have to try to relate each and everything. So I want to suggest you, both of you, that don't go with the formulas. Means in this type physics, in this physics, yeah, actually this is a mechanics. Yeah, in your 11th class, 80 to 90% is a part of mechanics. So in mechanics, uh, you have to think properly. Okay, so you should not think like that. If you will learn the formulas, and then you can solve the question easily, because in mechanics we have to apply our mind first, and there are some terms are there, I know, that terms we have to remember in your mind, and keeping that terms in our mind, we will we will solve the problem. Okay, so yeah, this thing I will suggest you. And, so I am starting from the motion in a plane, and this is also the part of kinematics. So kinematics, and please have the patience. And Divyangi, so you have a doubts in questions or in topics?
Sir, there are few questions.
Okay, so you can send me on my number, na? So I will solve that question. No problem for you.
Sir,
Okay,
I don't have a number.
so you do not add it to the group, na? So just I am saying to some the team that they should add you to the group, and when you will add it to the group, you can get the number and you can send your question. Okay,
Okay, sir.
fine. So now, Joylin and Divyangi, now focus. I am discussing the kinematics. Uh, in kinematics, you have, first of all, what is kinematics? You should know. Kinematics is the study of the motion without considering the cause of motion. Both of you, the cause of motion means motion is uh, this pen is moving right now. Okay, this, suppose this pen is moving like this, and the traffic on the road, and the person is going on a bike, and the earth revolves around the sun. These all are the motion. And in your 11th class we will discuss the motion of these things. Okay, the motion of a body and all these things. And for the study of the motion, there are the requirement of certain things, like we should know what is distance, displacement, speed, and acceleration, and you guys have already done that. So so in kinematics we have two chapters. First is motion in straight line. So in a motion in a straight line, you will only discuss the motion when a body will move along a straight line, or you can say along any of one of the axis, x axis, y axis, or z axis. Second is the motion in a plane. This we will discuss today. Motion in plane. And then this motion in a plane is divided into two parts. First part is the vectors and other is projectile motion. And believe me, this chapter vector means is one of the most important chapter throughout the physics, not of 11th, but of 12th also. In 12th also, the vector is the important part. Okay, so I will start from the vectors and Divyangi, I have already told you the basic of the vector. Is it or not? And
Yes, sir.
in our first class, but right now I am starting from the that was our trial class. So we will now start from the starting of the vectors. Okay, Joylin, is it fine?
Yes, sir. Yes, sir.
So I'm starting the vectors. So there are two types of quantities that everyone knows, that there are scalars and the vectors. But why there is a requirement of vectors? There is a requirement of the vector so as we can study the motion easily. We can analyze and study the motion of the body easily. That is why there is a requirement of the vectors. Okay, and when you will study the physics throughout the 11th class and the 12th class, then this you will get this answer why there are the vectors. Okay, so right now you cannot understand this, but uh, within the time you will get. So physical quantities, physical quantities. Physical quantity. Physical quantity means like the quantity which you can measure, like distance, displacement, acceleration, force, work, power, energy are the physical quantities. Can we measure the emotion? Can we measure the feeling? Can we measure the pain? No, we cannot measure. So that quantities are different. Here are the quantities which are physical quantities. Okay, physical quantities which can be measurable quantities. So in physical quantity in physics, we divide. There are two types of physical quantities. There are two types of physical quantity in physics. Number one is scalar quantities, and another is vector quantities. Everyone knows. Vector. Scalar and vector means you have listened the name also already. Okay. So for the scalars, if I write, these are the quantities having only magnitude, no direction. Only magnitude, no direction. Only magnitude means they have the numerical value only, like 2, 2, 3, 4, 5, like this. The number they have only. There is no description of you can say the direction will be here. Okay, there is no relation of these quantities with direction. So, for example, like distance, speed, power, work, energy. These are few examples of the scalar quantity. Now the vector quantities. Vector quantities have magnitude, plus they have direction, plus these vector quantities follow vector laws. Okay, follow vector laws. An example of vector quantities are force. Whenever you apply force, there is a particular direction of that. Okay. So force is a vector quantity. Displacement also. Acceleration. So these are the scalars and these are the vectors. Now, there are some classification of the vectors. There are some classification of the vectors. So we classify vectors in two ways. We classify the vectors in two ways, and I will tell you when you will study these types of vectors in different chapters. You will get that. So vectors can be classified as number one, polar vector, polar vectors, and another is the axial vectors. So what are the polar vectors? First, I will write the definition. So for the polar vector, you can say these are the vectors. These are the vectors. They are always act in a straight line. Okay, they act in a straight line. Act in a straight line. And also they have a starting point. Also, they have a starting point. Starting point. For example, from the example, it will be clear, like force, okay, like velocity. Force and velocity are the example of the polar vector. So when you will apply the force, that force will be in a straight line. Okay, always. So force is a polar vector. And axial vector. Axial vectors are something different. Uh, Axial vectors are the vectors which produce the rotational effect. Rotational effect means suppose a fan is rotating. Suppose your earth is rotating. And for describing the motion of your earth, there are some vectors. There are requirement of the vector. Those vectors we use axial vectors. And example of the axial vectors, like you have not studied the rotational motion. When you will study the rotational motion, there you will see there is one angular velocity, torque, angular momentum are there. So those are some different vectors known as the axial vectors. Axial vector you will study in a rotational motion. Okay, and also in a circular motion there will be a topic circular motion. You will study these vectors there. So axial vectors are the vector which produce rotational effect. They produce rotational effect, but at the same time, suppose something is rotating like this. This span is rotating like this. So for the rotation, we always define an axis. We always define an axis. This thing you will study in this rotational motion. Okay. So I am just giving you the brief idea about this. So these are the vectors which always acts along the axis. Okay, acts along the axis only. Axis of rotation. So this part mostly we will discuss in the axial vector, like the angular velocity, torque, and angular momentum. All these things we will discuss in rotational motion, and these things we will discuss in the projectile motion, in the Newton's laws of motion, in work power energy. Okay, in a straight line motion we have already discussed. Okay, so for example, you can write angular velocity. Like we have the linear velocity. When a body is moving in a straight line, you will have a linear velocity, and when the body is in rotation, at that time the velocity will be angular velocity, like torque. So now, so there is a requirement of the representation of the vector also. How we represent the vectors. So representation. Both of you getting my voice clearly?
Yes, sir.
Yes, sir.
Okay, fine. So how we will represent the vector and how we will denote the vectors. So notation is given like this. Suppose you have a vector A, so you will write this vector as A vector. A and arrow on that A. This is the notation. And for example, suppose it is written like force vector. This is the force vector. F, I am representing here a force vector. This can be written as 10 Newton due east. What is the meaning of this statement? This is the magnitude and this is the direction. Means 10 Newton force is acting along east direction. So 10 Newton is the magnitude and this east is the direction. Okay, this is written as this is direction. Now magnitude. How we represent the magnitude? So if you want to denote the magnitude of this A vector, so you will simply write this thing, mod of A, or simply you can write A. For example, you can write force like this, okay, equal to 10 Newton, or you can write simply F is equal to 10 Newton. So this F is representing only the magnitude, not the direction. Okay. Now there is the geometrical representation of the vector. Geometrical representation. This chapter to you, you may be feel like this is boring chapter, but believe me, this chapter is one of the most important chapter, I will say, because the vectors we will use throughout the physics. We will use vectors. Okay. So the basic fundamentals of the vector you should know. So geometrical representation. So geometrical representation of the vector is like this. Suppose this is the vector. So this is the arrow. Okay, this is the arrow, and the length of the arrow represents the magnitude. Length of the arrow represents the magnitude of the vector. Suppose the length of, there is some length of this arrow. Suppose this length is 10 meter, and I'm not writing the unit. 10 can be in meter. 10, there can be 10 meter. There can be 10 Newton. Okay. And this head of the arrow, this head of the arrow represents the direction of the vector. Okay. So this 10 is the length of this arrow, and this length of this arrow represents the magnitude of the vector. Okay. 10 is the magnitude. This is head of this arrow. This is tail. And the arrowhead here, the arrowhead represents the direction of the vector. Arrowhead will represent the direction, and length of arrow will represent the magnitude of, will represent the magnitude of the vector. For example, suppose you have a vector like this. So this is an arrow, and so you can say this is a vector. So length of this arrow will give you the magnitude of this A vector, and this arrowhead will give you the direction of the vector. Suppose you have a vector like this, B vector this time. So you can represent B vector, means this arrow will give the direction, means the arrowhead will give the direction, and length of the arrow will give the magnitude of it. So now if I am saying that I am having a vector like this, one vector is this. Suppose this is A vector, not A vector, A1 vector, this is A1 vector. And suppose if I am having a vector C vector, so we will tell which vector have the greater magnitude. I'm asking to Divyangi.
C.
C vector. Why? Because length of the arrow is greater. So C vector magnitude is represented like this now. So magnitude of C vector will be greater than the magnitude of E1 vector. So I am not talking about the direction here. And there are some basic things, Divyangi, I am telling again. And Joylin, you should also see this. In 20 minutes, I think we will finish this. And after that, we will discuss the unit vectors. So there are some basic definitions or some basic vectors, some basic terms. So first is equal vector. What are the equal vectors? Equal vector means the vector have same magnitude and direction. The vector will have same magnitude and direction. For example, you have two vectors like this. This is one vector, suppose, and this is another vector. So the length of the arrow of both the vectors are same, equal, and the direction is also same. Okay, from the arrowhead you can decide the direction, means this vector is going this side and this vector is also going this side. So here is this A vector, suppose this is the B vector. So you can say A vector is equal to B vector, and this can also be written like this. Suppose there is another vector which is like this. like this also. So this vector will also, you can say, was C vector. So A vector is equal to V vector is equal to C vector. All vectors have the same magnitude as well as direction. So that is why they are known as the equal vectors. And always remember that in this case, in equal vectors, always the angle between the vectors will always be 0 degree, because they will always be in the same direction. You can see angle between A and B is 0 degree, angle between A and C is 0 degree, B and C is 0 degree. This thing we will use when we solve the numerical. Okay, so angle theta, I am representing theta, angle between the vectors, always 0 degree. Angle between vectors, always 0 degree. Now another term is negative vector. Negative vectors. So negative vectors are the vectors, they have the equal magnitude but the opposite direction. They have the equal magnitude but opposite direction. Equal magnitude but opposite direction. What is the meaning of this? Means suppose you are having this vector like this, you have a vector like this and a vector like this. Means suppose this vector is this and this vector is this. So suppose this is A vector and this is B vector. So in this case, suppose the length of both the arrows are same, means the magnitude of A vector and B vector is same, but they are in different directions. Different direction means they are in opposite direction. Okay, opposite direction. One vector is going towards left, another vector is going towards right. Okay, so always in this case, the theta is 180 degree. There will be the cases where you will have the vector addition, and in that case the vector will be at in the opposite direction. Then in that case theta will be not given by the examiner, so you have to decide the theta. Okay, so here the theta between the two vector is 180 degree, and another vector is parallel vector. Parallel vectors. So parallel vectors are the vectors acting in the same direction. Acting in same direction. So what is the meaning of this? Suppose there is one vector and there is another vector. Here is another vector. Like this. So these are the parallel vectors. This is A vector suppose, and suppose this is B vector. So parallel vectors are like this. There is a condition only acting in the same direction, but there is no need. There is not necessary. This is not necessary that the magnitude or the length of the arrow of both the vectors are same. Can be same, but not necessarily. Okay. So magnitude you can write may or may not be same. May or may not be same. So anti-parallel vector. Now you can write anti-parallel vector. Anti-parallel means opposite direction. Vector acting in opposite direction. Anti-parallel vectors. Acting in opposite direction. Opposite direction means like this here. You can take this example. This is the example of anti-parallel vector, but here there is not necessary that the magnitude of a vector is greater than is equal to b vector. So a vector and b vector are anti-parallel vector, and in anti-parallel vector also the angle is 180 degree because they are acting in opposite direction. Okay. Now fifth is coplanar vector. Coplanar vectors. Coplanar vectors means suppose you have this plane. This is plane. Okay. And if the vectors are acting only on this plane, not out of this plane. Suppose there is something which is out of this plane. Suppose this is the plane now. So if the vectors are acting on this plane, then they are coplanar vector. If suppose there is any vector like this, okay, which is acting out of this plane, that vector will not be the coplanar vector. So for the coplanar vector, you can write vectors acting in same plane. Vectors acting in same plane. So same plane mean you can imagine this like the vectors which are acting on your screen. On your screen, these vectors are coplanar vector because these vectors are on the plane of your screen. There is a plane of your screen also. Okay, and there is a plane of copy also. So those vectors are coplanar vectors. So you can just, so these vectors are the coplanar vectors. If they are in same plane, then you can say are the coplanar vectors. Now co-initial vectors. Co-initial, co means same, initial means co-initial means the vectors have same starting point. Okay, co means same, initial means start, so same start. Okay, you can go with the word also. So they have the same starting point. Two vectors or three vectors, they have same starting point. Vectors have same starting point. So these vectors are like this. Suppose here is a vector, suppose a vector, and here is another vector, b vector. So both a and b vectors are the co-initial vector because they have the same starting point. Suppose in real life you can assume this as, suppose I am applying a force. Can imagine this like this. Suppose this is the point of this pen, and suppose two forces are acting on this point. Means someone is, I mean, two forces are acting on this point like this. One force is like this, another force is like this. So this is the example of co-initial vectors. Okay. Force is also a vector. So co-initial vector. So you can note it down now. And after this, I will tell you what are the unit vectors. And for the direction purpose, the unit vectors are very, very important. And Divyangi, I am just saying to team that they should add you in the group so that you can send me your doubt. Okay, note it down.
Yes, sir.
So if you have any doubt, both of you, then you can ask me. And please remember one more point: when you will study physics, always there will be a doubt. So Joylin, all points are clear to you?
Yes, sir.
If you are not getting any letter or any word of my writing, then also you can ask me. So Divyangi, are you writing or taking the screenshots?
Sir, writing.
And Joylin,
Sir, I wrote.
you are writing or what you are doing?
Sir, I'm writing.
Done, sir.
Joylin, should I scroll down?
Yes, sir.
So Divyangi, do you know what is work energy theorem?
Sir, that chapter is yet to be revised.
Okay.
Sir, can we say that circular motion is a combination of two variable vectors?
Variable vector means the circular motion. In a circular motion there are certain number of vectors. In circular motion there is a centripetal force, okay, and force is a vector, okay. So and there is a velocity, okay, and there is angular velocity. So you can say that circular motion is a combination of polar vectors and axial vectors. This is the right term, I think. I have understood your question, what you are saying. Got it now?
Yes, sir.
Means in circular motion you will have the angular velocity also. You will have the angular velocity also. Angular velocity is the again axial vector, but at the same time for performing the circular motion there is always a requirement of centripetal force that we will discuss later, okay. And also there will be a linear velocity, and that linear velocity will be tangential to that the motion of the particle or the object. So that is a linear thing. There are both the things, the linear and angular things, okay. So you can say the circular motion is the combination of means both types of vectors we have.
Written, sir.
Okay. So Divyangi, written. Oh, sorry, Joylin.
Yes, sir.
Divyangi, do you know what is centripetal force?
Yes, sir.
What is this? And just
Sir, it's
yeah. Hmm.
sir, is it provided due to the acceleration?
Mhm. Yeah, right. You can say centripetal force is a force which is required in a circular motion, and we cannot say it is provided. This is not the right statement. Means provided by the acceleration. Uh, you can say
Sir,
this
it's due
force.
to friction.
This centripetal force can be by some external force. This can be by the friction. This can be by the electrostatic force. When you will go in the 12th class, then you will see there are the electrostatic force. Means like you can take the example of the atom. In atom, in the center there is nucleus, and electron revolves around the nucleus in a circular orbit. Okay, so there that centripetal force, and always remember that for the circular motion there is always a requirement of the centripetal force, and that centripetal force will be always provided by some external force. And in case of the electron revolving, that centripetal force will be provided by that electric force in between the nucleus and the electron. So there you will study this thing. I think you will study in the chapter, in the electrostatics also, or in atomic structure, and I think there you will study. So you can write for the centripetal force. Centripetal force is that not our topic. I'm just generally I'm telling to you. You can write in the exam that centripetal force is a force required for the motion, for the circular motion of any body, and this is provided by some external force like the friction force. Okay, so and like the gravitational force also, like you can say the earth revolves around the sun. So can you think how earth can revolve around the sun? Why? Because there is a centripetal force, and that centripetal force is provided by the gravitational force. In ninth class, I think you have studied the Newton's law of gravitation. Force is equal to product of masses divided by r square into capital G. So that force provides the centripetal force in that case. Should I scroll down?
Yes, sir.
Yes, sir.
Okay.
Sir,
Yeah.
sir, so the derivation of centripetal force and centripetal acceleration will be different?
No, both are same. Means there will be no change in that.
Okay, sir.
Yeah, because we know that force is equal to mass into acceleration. If you know force, then you can calculate the this acceleration. Okay.
Done, sir.
When there will be a circular motion topic, no? So there are the few terms in the starting you will study, like the angular displacement. After that, you will study the angular velocity. After that, you will study the angular acceleration. And there, so the teacher will tell you how to calculate the angular acceleration. Angular acceleration is represented by this alpha. Okay, okay, alpha. These all things there we will discuss. And that angular acceleration, when you will multiply with mass, not angular acceleration, linear acceleration, when you will multiply with mass with the help of angular acceleration, then you will get the centripetal force. And one thing more about the centripetal force, always act along the center. Okay, so completed this, both of you.
Yes, sir.
Yes, sir.
Please note it down. What was I asking? Yeah, of course, centripetal acceleration is a linear acceleration. You are right.
Okay, sir.
Okay. There are two types of acceleration in circular motion. One is tangential acceleration, another is centripetal acceleration. So centripetal acceleration acts along the center, and tangential acceleration will be along the direction of the velocity. Okay. There are four types of acceleration basically you have. One is centripetal, another is tangential. Okay. And when you will take the net acceleration of both the acceleration, another acceleration will be an angular acceleration also. Basically, we have in total four types of acceleration. Not the type, but you can say four acceleration. You will study in this acceleration. So this is completed now.
Yes, sir.
Okay, so now unit vectors. Unit vectors. So unit vector, unit means one. So unit vector, you can say vectors have magnitude 1. Magnitude unit magnitude, you can say. Right term is unit magnitude. Unit magnitude. And direction can be any direction. And these unit vectors, suppose I am saying unit vector of A. So these unit vectors are represented by this cap. Okay. A and this cap on A. This is unit vector of A. What is this? Unit vector of A, you can say. And magnitude of these vectors is equal to 1. And the direction can be, for example, you have a unit vector, suppose I'm taking this time unit vector of small n, and this small n vector is acting in this direction. And there is another vector, means suppose unit m vector. Suppose this vector is acting in this direction. So the magnitude is 1. If you want to calculate the unit vector of any vector, suppose you have a vector A, and of this vector A, you want to calculate the unit vector of this vector A. So you will write this vector as, first you will write A vector and divided this with the magnitude of this A vector. This is how you will write the unit vector of any vector. For example, you have a vector B vector. Okay, we'll discuss this question later. So this is the unit vector. Now there are universal unit vectors. There are universal unit vectors. Unit vectors, universal unit vectors. So this thing I will explain with the help of the coordinate axis. So this is suppose y-axis, x-axis, and this is z-axis, and this is plus y-axis plus x-axis, and this is minus x-axis, minus y-axis, minus z-axis. So universal unit vectors are I cap, j cap, and k cap are represented by I cap, j cap, and k cap, and they are the unit vectors, means they have the magnitude 1. But what are the speciality of these vectors? These unit vectors help us to understand the direction of the vector, means in which direction the vector is going. So the vector means this I cap vector always act along the x-axis, and this minus I cap vector means this is I cap, and you will write just minus sign and I cap, and this vector will represent the negative x-axis, and this is j cap, this is minus j cap here, and this is k cap, this minus k cap. So I, j, k are the vector acting along x-axis, y-axis, and z-axis respectively. So I cap, you can write unit vector along plus positive x-axis, similarly you can write j vector unit vector along positive y-axis, k cap can write unit vector along positive z-axis. For example, suppose I have written here f vector is equal to 5 I cap Newton. So what is the meaning of this? The meaning of this is this I cap represents what I cap represent means positive x-axis means in this direction. This is the origin. Okay, this is the origin. The meaning of this now is a force of 5 Newton acting along x positive x-axis. Okay, so this I cap is representing the direction. This is the magnitude. This I cap represent the direction. And direction you can say along x-axis or you can write positive x-axis. And magnitude it is equal to 5 Newton. So in this way also you can identify the direction of the vector. Suppose I am saying displacement is given, as is the displacement is given minus 20 into k cap. So see this first now. See this diagram. Both of you see this diagram. Take 1 minute. I am having another class, guys. So see this diagram, and in this diagram you can see there are different vectors. So Joylin, just tell me what is the magnitude and what is the direction of this displacement vector?
So magnitude is -20, and then it's the direction is in the y-axis.
Okay, just
No, z-axis.
your answer is 50% right. So I can write actually magnitude cannot be negative. Okay, so you can write this 20 into minus k cap. So this is the magnitude and this is the direction, means direction is negative z-axis. Okay, just fastly write it down, and I have the another class after this. Someone is waiting. And Divyangi, I have told you to the team. You have added, I think, to the group, and there you can send me the questions. And I will be free today at 11. So after that, I will send you the answers. Okay, fine.
Sir, I'm not added.
You have not added. No problem, you will be added. Don't worry. So from where you will write? From here. Just write it fast. Someone is waiting. I am in another class. We will meet in the next class, and I am saying that
Sir, taken the screenshot.
okay. So Joylin,
Yes, sir. Yes, sir. I've written it.
you are writing now?
Yes, sir.
Okay, just write. No problem.
Sir, I wrote.
Note na? So, okay. And this thing is very important. I am saying again and again. And I think Divyangi, I have already told you this thing. And I am telling this.
Done, sir.
Yes, sir.
Both of you.
Yes, sir.
So just write this, and we will meet in the next class.